Hey, what's going on, guys? Xiangqi PGN here. In this video I'd like to introduce the new updated version of my CNC puzzle solver. So the previous prototype had only 3 games, and the problem was actually in the lack of sorry, only 3 positions, and the problem was actually in the lack of puzzles themselves. So what stopped me from kind of providing really lots of puzzles like it is now was the lack of data set to extract the puzzle positions from. So now we have from mate in 1 really lots of mates in 1 here, so it's around more than 1,000 mates in 1. Then we have mates in 2, really quite pretty a lot. Okay, we also have mate in 3, mate in 4, and after mate in 4, just to make this a little bit more interesting, we have mate in question mark sign. In question mark move. So don't know how many moves, we just know that the side to move is actually mated. So this is kind of it. And one of the most amazing things regarding this puzzles is that all of these puzzles are verified by the CNC engine that I've written. So I just made sure that none of puzzles is broken, so they all kind of working nicely. The number of moves in order to achieve the mate should be correct, but sometimes, well, if you find some like it's made in 2 while it's print like it's made in 1, made in 3, it prints that it's made in 3, but on the real deal this is kind of made in 2. Well, I'm sorry for that. So there might be some minor inaccuracies, but generally there shouldn't be any. So actually, these positions with mate in question mark are those that I couldn't really, well, at least I couldn't make it that easy, that simple to figure out how many moves it's needed to get this, because when I was using the fixed move, the fixed depth, it wasn't always enough to find the mate, and running this with a deeper depth, like not 10 plies, but let's say 15 plies, in that case that would have taken kind of too long to generate the data set. I didn't really want to go for that. So here we just can say that we definitely do mate here, but not always sure how many moves it takes. But anyway, the puzzles should be valid. So let me quickly solve a few first puzzles that are very beginner friendly, and then I'll quickly highlight the implementation, so what the work was done in order to achieve this sort of a result. And by the way, yeah, obviously, so it's already available. It's alive in the live mode, so it's deployed on GitHub. So feel free, so you can just navigate with this link. I'll give you a link in the description below the video, so you can just navigate here and start solving up to 3,386 puzzles. So I think this is really this would really improve your CNC playing skills. And obviously these puzzles can be easily updated, so there is a way to add new puzzles programmatically. In that case, you may make a pull request to the project or something. So if you just download this, it simply relies on, so let me just open the new tab. So it simply relies on, sort of better new window, it relies on okay, apps puzzle solver GUI game puzzles.js. So here is the file it relies on. So we have the list of dictionaries, or the list of objects in terms of JavaScript. So we have a description, FEN string itself to load to the engine, the ID, and the title, like how many moves we have. So we have really lots of data here, but obviously you can append new either by hand or programmatically, doesn't matter really. So I hope this is clear. Okay, and yeah, and obviously whatever position we select, we have this like puzzle number, how many moves. So this is handy if you just forget where you've stopped, so you can store it locally somewhere. And also all the positions are has been depicted from the real world games from the CNC master database I've scraped earlier. So we see like who was playing red and who was playing black. So all the positions are from the real games. That's another benefit. So they are not artificial. This is the real world games position, which I think benefits the idea of solving the puzzles. So that's gonna, okay, let's just try quickly solve a few puzzles here, and then I'll go describing on some descriptions on how did I manage to come up with this sort of a stuff. So made in 1, red to move, and let's think. So let's say if I take with this rook, it would be check. So king can capture because rec king is protecting the rook, and the only thing that can capture is this advisor. But if the advisor captures, then we would be having the check from this cannon. So this should be a mate, and engine confirms. So we got a mate. Just to give you an idea that on any other move. So let me just yeah, and also it automatically goes to the next puzzle after 5 seconds. So just to give you time to realize that this is really a checkmate. So if you just go back, let's say I do whatever else move, so the engine just would be playing. Okay, so you're no longer mating. Well, maybe you still can mate. That might be possible, but yeah, but already it's not a mate in 1 anymore. So if you don't mate in 1, you're still you're still able to play versus engine in this position, playing moves, try to mate. But yeah, engine can crush you. It's not a big deal, but you're no longer able to actually win this. So in mate in 1, you can just mate, and this is it. And after 5 second passes, it just redirects you to the next position. So here is the next one, and well, you can pause the video, try to guess the move. So let's see. So king can go here because knight attacks, right? So the only way king can go is over here. But if I check with the cannon, then nothing can be done with these 2 cannons. Also, king can be defended. And if, let's say I go here, and advisor defends, then this cannon would be attacking the king. So this is the checkmate. Okay, another brilliant checkmate. Okay. And the next game, so this is a little bit more complicated at a glance, but also a very nice move. Can you spot the move? Okay, here is the move, and we got a checkmate. Okay, so okay, I don't remember if I did actually. Yeah, so here should be the knight goes. Yeah, here it should be. This should be a checkmate. Cool. Okay. Yeah, now this position is interesting. It took me a bit of time to come up with a solution. I was trying different moves, like moving the rook, capturing bishops, but this obviously it's not mate in 1, but here is a very tricky move to mate the opponent in 1 move. Can you spot the move? Pause the video. Okay, so for those of you who has already guessed, this is the move. And so on, and you can really do this for a kind of long time. So 3,386 positions, including those where you don't know how many moves exactly it takes to win. You might have encountered a position when you are in the check as the side to move, and in that case you also need to defend appropriately in order to lead the game to the sequence of the winning moves that eventually leads to the checkmate. So what I can say for like 100% sure is that whatever position out of this 3,000 plus positions would actually lead to the state of the game where the side to move checkmates the opponent. So that's kind of it. So feel free to enjoy this stuff, and now let's quickly walk through the source code that I've written in order to extract actually this sort of positions. So there were a couple of issues, but I think this might be interesting. So yeah, by the way, now we have the opening book generator, a single folder, and puzzle generator also single folder. I could have cleaned up the structure even better, but unfortunately I'm sharing the links in the previous videos, and the previous videos are already kind of binded to the specific locations, and I just don't really want to change the links in the previous videos. So the price for that is that the project structure is not always that brilliant. But anyway, so here within the puzzle generator we have up to four 4 scripts to run one after another to come up with the eventual data set that is stored in this puzzles verified.json file. And then I just grab this JSON file and I just paste this JSON file to puzzle viewer to initialize the variable called puzzles, const puzzles. That's kind of, so just grab entire stuff from here and copy paste into that file. So I hope that's clear. So we start with parse.js. So it takes it relies on CNC parser, which on its own relies on Wukun engine to verify the stuff and just to be able to make the moves on a board. And the file for games. Well, here in order to not in order to avoid making git repo too big, so I'm using a little sat here. So I'm sorry. Is this? Hold on a sec. Parse.js games. So yeah, I remember I had a small number of games here. Yeah, it's a small file. Not all the files, or not all the 40,000 games I have, but just a small one. But you can always. But hold on a sec. No, this games. There should be a bulk games. No, hold on a sec. This probably generate games. Oh no, this one generate. Yeah, it generate games. So I'm sorry. This file is actually produced by the parse.js. So here we have only a little sample, but on the real deal, in order to come up with those, with all of those positions, I was processing the file of 40,000 games, so even more than 40,000 games. You can have that from CNC database, games PGN, and bulk games UCI PGN from this one, I guess. No, this again. No, this is a little sample again. No, so not here. Then you can take it from UCI from here, 40,000 games. So you just unpack, and then you can use that file. Well, actually, it seems like games PGN, bulk games UCI. I'm not sure. I probably. I don't even remember that. Yeah, I should specify. I definitely should specify. So now I guess the parse.js just won't be working simply. Hold on a sec. If I just say Node.js, parse.js, it won't be working. Just doesn't have this bulk games PGN. So I paste this in. I rename it to bulk games, and I just want to make sure that the format is appropriate. Bulk games. Well, let's try to run this. I think this is. Oh, whoa, nope. So probably it relies not on the UCI format, but on the international format. Okay. CNC database. Yeah, let's try this one. Copy. Okay. Sorry guys, just I should have done this before recording the video. I was really sure that I was really sure, yeah, probably this is the source. I was really sure that I did this already. Yeah, now it's fine. Yeah, so we've processed all of these games. And yeah, just the output has been updated. So this EOD means end of description. It's just a separator to distinguish between the headers and the actual games and the actual game moves. So please know that we don't have any like move numbers because this string is already an input to engine's function that is called load moves. So we can simply use this, just splitting this line. We're just taking this line and passing this to load moves. That's how it works. So the first script is trivial. It simply converts simply converts this sort of a file to this sort of a file, and now we can use this strings for moves in order to feed the engine itself. So what happens next, we go to the puzzle generator JS. So now it takes this games PGN, so this file that we've used, it just splits the description and the moves, and what it does next, so it just loads moves. So it starts it initializes the new game, so engine starts from the start FEN, then we load in moves, and then we call in search at the depth 8. Well, this is arguable how many plies to use here. So this is limited to search to made in 4, but there are positions where it's more than made in 4. Well, probably made in 4 is also, well, it's questionable. It's hard to say, but even with this depth 8, it took me a couple of hours to complete the entire script by processing the entire 40,000 games. So well, that's kind of trade-off here. And then in case I've also modified the engine code a little bit, so just slightly modify the engine code in order to it returns a bit, the search position function returns in a little bit different format. But anyway, so if we have a maiden score after this search, so not all the games end up with a mate. So there are many games that actually, you might wonder why we have only like 3,000 of maiden and moves from 40,000 games. Well, that's because the vast majority of the games were ended by the resignation, and absolutely not obvious the mating position was on the board. So it's like just a piece up, just a couple of pieces up, just totally crushing position, so no sense to continue. So really lots of games end up like it's just opponent resigns and that's it, but it's not yet a mate. So just like in international Western chess, it happens absolutely the same. So we do extract all the positions. So by loading all the moves, engine encounters a position where the game has ended already. And when the game is ended, we need to ask a simple question. So whether it has ended because of resignation or because of a mate that is threatening. So in exactly in the case if the mate is threatening, so this is the condition. In this case, we just extracting the how many mate in how many moves is threatening, but again, like, it's a little bit of an issue because the engine counts the mate in plies, not mate in moves. So ply means half move. So there is an additional logic to convert this half moves to moves, which mostly works fine, but sometimes it might be given small errors. But anyway, also we need to extract the description from the header of this. So also we need to generate the FEN string from the position resulting from the resultant position. So we make all the moves, then we need to generate the position FEN, that's the string to encode the position, and then we also need to associate the game credentials with a certain position that we have. So that's exactly what happened. So we associated the description, the FEN, and before that generate FEN. Yeah, before that we did generate FEN. So here I drafted the function to generate the FEN string from. So just to give you an idea what the FEN string is, this is the FEN string. So we have the board position, the left part, and then we have the side to move, and this just can be ignored. It doesn't matter much really. So like for international Western chess, this makes sense, like in peasant square and castling rights. Sorry, first castling rights, then in peasant square, then number of moves in regards to 50 rule move counter, and the last one is the full game counter moves, but that doesn't matter for Xiangqi and in particular for this puzzle. So we only need to make sure that we have the correct position, the correct side to move, and also we have the correct position. That's enough to initialize the actual board position and to specify the side to move. By the way, please note that if it's black to move, the app would automatically flip the board for you, so you would be solving this from the black's perspective. While if this is the matter of like a white to move, then you say like here we're solving this from the red perspective, like sorry, not white to move, red to move. So either red or black to move, or either red or black to mate, the board would be flipped, sorry, accordingly, respectively. So I hope that's clear. So yeah, here we just generate the initial data set, and this puzzles JSON. This is how the initial set of puzzles kind of looks like. So puzzles JSON, here is the file. So it doesn't have any ID yet. It just have the title, description, FEN, and mate is still in plies, not in moves. So like this made in 6, it doesn't mean that this is made in 6 moves. It means that it made in 6 plies, literally made in 3 moves. So I hope that's clear. And so this is the data set that we're supposed to be working with next in order to filter it and make sure that the number of moves moves that have moves are converted to plies. And also there was a horrible issue, like we have a made in, I don't know, x n position, made in n moves, but it was happening, well, in particular it was happening, let me recall the game, don't remember which one. I can't find it now, but it doesn't matter. So there were positions where it says like it's white's turn to move, and let's say made in 3 moves, but actually white loses in 3 moves. So that means that we need to convert that position to actually black to move. So we need to make 1 move for whites, and then we need to regenerate the FEN again. And this is one of the main jobs for the next script. So the next script was so this puzzle verification. So first we've used this puzzle generator to generate this sort of a data set, and then we're going for puzzle verification, which allows to get rid of this tricky things that I've just described. So we have 2 cases. So if the puzzle is okay, which means that the winning side and the side within the puzzle are equal, and otherwise we need to fix it. And fixing means, like we just said in the FEN, we're making the first move. That is also we're collecting the moves that are within the puzzles for 2 purposes: just to make the move, to fix the puzzle, or otherwise just to oh my god, just to convert the number of to convert plies to moves. So here we divide it by 2 and round in to make sure that we're having the number in plies in moves, not in plies. Well, I really suck in math, so this might not be, probably it might not always be the case, but I hope that in general this should be more or less kind of fine. And then we just regenerate the FEN for this new position. So when we made the first move, so let's say, again, imagine the situation we have like white to go, made in 3, but actually white gets mated in 3 moves. No, it doesn't matter what it does. So in this case, we need to make the first move by white, and then we want to swap this side, and then we already have a position not made in 3 but made in 2, and now black to move, and now the position is fixed. So we have black to move, made in 2, you just make the move and make the opponent, that's it. So this is the major goal of this puzzle verification.js script. And this script on its turn, it creates this puzzle verified JSON. Already has the puzzle ID that would get sorted later on. Well, I could have sorted this before, but when I was doing this I wasn't really thinking about that much. So here we already have so this should be already kind of correct kind of stuff, but still, when we have here are some positions like made in up to 98, if I'm not, 94 moves. Can you believe this? I don't know, probably some sort of a bug or something. So I've dropped this like positions. It seems like the engine still finds a mate there, but I don't know, just I don't know why this happens. Actually, just didn't really want to spend time digging into the reasons behind this. But anyway, so this is the next document. This is the next output file to work with, and finally and eventually we have the sort puzzles, which actually sorts the puzzles in. So we have first we have this made in 1, then made in 2, and so on, made in 3, made in 4, and all the guys that where we have more than made in 4, that probably something has gone wrong. So to make sure it kind of works nicely, I just replaced the number of moves by the question mark. So from the plain perspective, it's still incredibly interesting to find the mate, but I just didn't really want to spend time on writing the logic to figure out how exactly moves is there, because that was just a little bit boring. So I decided to just keep this made in question mark moves, and eventually we have this kind of application with really lots of interesting positions to solve. And yeah, and like the eventual data set is puzzles verified and sorted.json. So here is the eventual data set that I've already copy pasted into my puzzle solver. Okay guys, so this is it from my side. I hope you've enjoyed the video. So the process of creating puzzles for CNC, and this might be applied to chess as well. So this is quite pretty simple. I would say even trivial. So nothing really complicated here. If you're doing data extraction daily, like I do in my freelance jobs, at very least. So yeah, this might be a very interesting exercise to practice your coding skills, especially bear in mind the fact that eventually we have an absolutely fantastic app to play with. So I'm really tempted to solve these puzzles one day, eventually probably solving all of these puzzles. I'm just a little bit short of time at the moment, so apart from my daily job that I have, like my freelance job that regards to web scraping and data extraction, I'm working with Xiangqi PGN, the author of cncinenglish.com site. So we're trying to I will try to write some script to help him to automate the process of transforming the ancient CNC manuals to the modern format, to the modern form, including PGNs and even pictures. I have no idea how that would have been done at the moment, so really lots of work, but it's quite pretty interesting from the data extraction perspective. And I hope to take this automating of this automated work with the CNC related data to the next level, and hopefully we would be able to do something really interesting together with Jim. So this is it from my side, guys. Thanks for watching. Until the next time, and take care.